Hello everybody, today we will be looking at programming an ATtiny167, and the first thing we are going to do is just going to get a simple LED to blink. We're going to set this all up, we'll set it up on the computer and everything like that. I'll have two separate videos, one for Linux and one for Windows. So this, if this isn't your operating system, then you might find in the description the video for the other operating system if it is done at this time. What we have here is we're not going to have all this set up. For example, you won't need this whole module over here. But right now I just have a lot of stuff connected up, but we won't be doing all of that. We are simply going to upload a program so that we can do a simple blink program. And then we are going to look at something a little bit more complex, such as powering this adafruit neopixel. Now, these chips are very small. They are this small compared to my finger, and they have 20 pins. This ATtiny167, it has 20 pins, 16 kilobytes of flash, and it's quite a powerful chip for how small it is. So if you're creating a project or something like that and you need something small and multiple pins, then this may be the chip you want to use. So what we have here is everything that you're going to need is obviously a computer, and then we'll need a programmer. In this case, we are using the ArduinoISP over a dual-leve. Now this works pretty much exactly the same using an Arduino Uno if you have that instead, which most people will. And the other thing you're going to need is a cable for that. And if you do not use the Arduino ISP programmer, it may be a bit more complicated, so I would advise to follow it this way, at least at the start. Now, we also will need a capacitor, a 1 to 10 UF capacitor, and then to hold the chip, we have this SOP28 dip, and you can see it just goes right into here. You can pull this out by pushing down, and then you can pull it out and put it back in. Alright, so the first thing that we need to do is actually set up it so you can program the ATtiny167. So the chip over here, that's the ATtiny167. I have all the pins labeled and things like that. Now, this is going to be on top of the SOIP adapter, which goes onto the breadboard, as I showed you in the previous part of this video. And this is where we're going to use the 1 to 10 UF capacitor that I was talking about earlier. Make sure that the positive side is going to reset and the negative side of the capacitor is going to ground. The way you know that is that the positive side is longer than the negative lead. So that's how you know which way to put the capacitor in there. Now, the next thing is the actual reason that we use this capacitor is because sometimes when we're uploading the sketch to the ATtiny167 or any chip for that matter, sometimes there's some sort of power issue and the whole Arduino Uno just randomly resets. And this capacitor somehow fixes that issue. Now the next thing we want to do is actually power the ATtiny167. And that can be done from the positive and negative from the Uno, or whatever Arduino chip you're using, Arduino board you're using. So I'm going from the 5 volt down to the VCC on the ATtiny167, and as well as the ground to the ground on the 167. And you could use this pin for ground, but that's already used, so might as well just use this one. Now the next thing is connecting all these pins. Now these are the pins that actually do the programming to the chip, and all that type of stuff. It controls the chip. So from pin 31 or pin 13 goes to pin 8, and that's because of the SCK. That's mainly what we're trying to connect. The SCK from pin 13 to the SCK on the ATtiny167. So that's the main thing that we're connecting for that. And then for pin 12, we're connecting 12 to pin 3 on the chip. And be sure that you have the chip oriented correctly. There'll be a little dot on the top left of the chip so that you know it's oriented correctly. Now for pin 12, the main thing we're connecting is the MISO, M-I-S-O, master in, slave out. And then the next part is pin 11, and that will connect to pin 7 on the ATtiny167. And the main thing for this one is MOSI, M-O-S-I, master out, slave in. And then finally, pin 10, we are connecting up to pin 11. And the main reason we're doing that, the reason we're doing that is because of the reset pin on the ATtiny167. That's the main reason why we're going to these specific pins, because they have those specific properties. Now, the last thing is the actual LED lights. Now, these aren't necessary, but it's definitely useful in programming, and it's pretty simple to set up. It goes along with the ArduinoISP program. It's part of the ArduinoISP program that shows you what's going on. So the 9 on pin 9, the LED, make sure you have positive to the actual pin 9. That's the longer side of the LED, and then the negative just to the negative. And what I do is for like the ground and the power, I usually on the breadboard put it to the long strips on the side so that we get a full power rail of positive and negative, so that we can easily connect these LEDs up to the negative rail on the breadboard for each of these. So we've got pin 9, 8, and 7. Now the LED on pin 9 shows that the programmer is actually running. It shows that it's on and working. Pin 8 is an error LED. It shows up when the sketch fails to upload or something like that. And then pin 7 will blink whenever it's communicating with the ATtiny167 or the slave, whatever you want to call it. And by the way, these pins are described in the ArduinoISP program, which brings me to the next point. We need to upload the ArduinoISP code onto the DuMLeve before you put on the capacitor. Whenever you're programming the DuMLeve itself or the Uno, whichever board you have, the programmer, what you're using as a programmer, you need to take off that capacitor. And after you do that, what you do to get to the ArduinoISP is from File, Examples, and you should have ArduinoISP built in to the Arduino software, and it will open up this. And if you scroll down, you can see it does have all these the pin setup right here, and also down here for the MOSI, MISO, and SCK, just in case you need to know that. So that is what you need to upload to the DuMLeve or Uno, whatever board you're using. Just make sure that you put the board onto your correct one. If it's the Uno, do the Uno. If it's DuMLeve, set it to DuMLeve. Make sure you have the right processor set up and the port. And then just choose upload. And that will upload onto your Arduino board, and then you can use it as a programmer. And after you upload it, put that capacitor back on. After you get the board and all the wires set up, now we can move on to actually getting it so we can program it from the computer. Now when we go into File, what we need to go into is Preferences, And then under Additional Board Manager, now this is assuming that you have the latest Arduino. You should have Arduino 1.6.8, 1.6.7. It should also work as well, but 0.8 is the latest. And what you want to do is go into this Additional Boards Manager and enter in this URL. And this will be in the description of the video, so you don't have to copy from this video. Now choose OK, go into Tools, Board Manager, and then let it download the files, and then go under Contributed, and you'll see two ATtiny packages that you can install, either this one or the ATtiny core. What you want to do is get the ATtiny core. And since mine is already installed, I don't need to install again, but you just simply click on this and click the install button. Now, after this install, it is important that you do not choose Burn Bootloader from this menu, because this may cause your ATtiny167 to be soft bricked until you fix it by adding a clock, basically a constant clock rate onto the 167. This is due to some bug in this repository. It's setting the wrong fuses, therefore causing the 167 to try and use an external clock instead of its internal clock. Now, in order to get this right, now when you buy the ATtiny167 chip, it does come with a 1 megahertz rate, and this is not good enough. This is not what you want when programming Arduino. You're going to have a lot of issues if you keep it at that rate. For example, if you do the blink program for 1 second, it's going to be either extremely too long, for example like 5 seconds, or extremely too short, depending on your setting. Now, to avoid this, you actually do need to burn a different bootloader or set the fuses. In order to do this, we need to add compatibility for the 167 into the avrdude config file. So we need to add support for avrdude. If you don't know what avrdude is, it's a program that allows you to do various things on the AVR chips. And what you need to do, we need to go to this link, and I will leave this in the description as well. And what you want to do is just copy this part of his comment. And what we need to do is add this onto some files. What you need to do is go into either the user share Arduino hardware tools AVR etc avr.config, or /home/ your username /.arduino15 packages Arduino tools AVR dude 6.0.1 Arduino 5 /etc /avrude.conf. Either that or both. So for example, in your home folder you should have a Arduino 15 folder, and this may be you may need to show hidden files as a setting in your file manager to get to this, and then go into packages Arduino tools Arduino avrdude, and then etc, and then you finally get to avrdude.conf. You can see Control L, you can see the location. So I'll leave these two locations in the description, and you also may need to use sudo if you have gedit on Linux, or whatever text file editor you have, you can use that. For the slash user file, you will need to use root. So you can either type in su first, or you can do sudo and then the command. And I'm using gedit. So we have gedit, the location, your password, and then you can get into the file. Now, when you get into the file, just scroll all the way down to the bottom. Make sure that you have the file, the contents copied from this post that I had up. So copy that content and simply add it to the very bottom of the file. So if I copied this and pasted it into here, that's all you needed to do. But I already have it, so I'm going to do Control Z to undo that. As you can see, it has code for the 167 as well as the ATtiny87. That's because these chips are pretty much identical, just some slight differences. And what you want to do from there is save. And after you've got that saved, you can go on to the next step. What we want to do is go to this link, TC World link, ATtiny Core, etc. And what we want to do is download the ATtiny167 hex file. So it's empty167.hex. Just press on that, choose raw, and it should go ahead and give you the raw file. And then right click, choose save as, and just save that to your download. Now what you're going to need to do is move that into the location that you have avrdude. Now in Linux, you should have avrdude in /home/Michael, or your username, /Arduino15 /packages/Arduino/tools /avrdude /6.0.1 -Arduino5 /bin. It might be slightly different, maybe based on your version or something like that, but this should be the correct location in Linux. So from your terminal, you can go ahead and type in cd and the location, and I'll have this in the description as well. First copy over the hex file into this folder. So what you want to do is, first of all, let me check if I have the file already in here, which I don't. So what you want to do is use the mv command or cp command and go into /home, your username, downloads, and then empty 167.hex, and then space, and then dot, and that should move it to the current folder. So if I do ls now, I have the file. Now the next command is quite a bit long, so I'm just going to copy and paste. What it is this avrdude command. You should make sure that you have avrdude in the directory that you're in, and we can use that command, which it actually already processed. If you don't want it to go automatically, make sure you don't have a character after, make sure you don't copy a character after the line of text, which is the enter character. But what it is /avrdude-c avrisp-p t167-p, and then the location for your device, for your programming device, which we're using the Dumaleve. And if you check the Arduino software, you can see that the port is /dev/tty USB 0. So that is why we are setting it to that. -B, this is the baud rate, -U, this is setting fuses, the external extended fuse, the high fuse, the low fuse, and we're flashing the ATtiny167 hex file right here. And what you do is press enter and it will run through this, which I already did. You got to make sure the chip is all connected up correctly. Now it is using 8 megahertz internal clock processor. And that is that. For this example, it does use the /etc. I believe this uses one of these config files. It might be the etc config file or the one in .arduino 15. I'm not exactly sure which config file it uses, but I did add one /etc/avrude. I did copy the configuration from the other file into /etc/avrude just in case. So if you're having any issues, for example, if it says it can't find the configuration file, or it can't find T167, then it's just a configuration file issue, and you need to either copy that text that we used for the 167 into the config file, or do something else. It should be pretty obvious. So now that we have that set up, I know this is a long process, and it really is. It was quite complicated to get set up, especially the first time. So now that we have that set up, we can go ahead and start and set up the board so that we can upload the Blink program and test that. So here I've added an LED to pin 13. So on pin 13 and on the ATtiny167, that's where we're going to have the blinking LED. What we want to do is go into the Arduino software, go into File, Examples, go under Basic, and choose Blink. Set this to pin 13, which I already changed. You'll need to change this number and this number and this number in order for it to all work. And then what you want to do is go into Tools, and for the board, go down and choose the ATtiny87 series, which this is what we installed earlier from the board manager. Now go into Tools, and then make sure that BOD is disabled. We don't need that. We need this on New Style. Chip is the 167, not the 87, and the clock is 8 megahertz internal, and the port is /dev/TTY-USB, and the programmer is ArduinoISP, so make sure it's set to that, or else you'll have issues. So what you want to do now is you can simply choose upload. After you've got the LED on there, it should upload pretty easily. And now you can see it running and it's blinking. Now we are going to go into a bit more complicated example, just so I can show you all these external libraries that will work for the ATtiny167. Now the first thing is we're going to test out the Adafruit NeoPixel library with an Adafruit NeoPixel 12. So what we're going to do is go ahead and download this library from github.com/adafruit/adafruit_neopixel, and this is going to be in the description as well. Once you have it downloaded, it should be in your downloads folder, and what we want to do is go into the Arduino software, go under Sketch, choose Include Library, go to add.zip library, and then go under Downloads, and you should see the Adafruit NeoPixel library. Now just press on that and choose OK. And now it says library added to your libraries. Check include library menu. Now go into File, Examples, and under the examples, under adafruit neopixel, choose strand test. Now this is just a simple program that tests the neopixels. Now we only need to change a couple of things. Let me first open up the schematics and let me show you the setup real quick. So here's the updated diagram. So what we're using is pin 13 again, and instead of the LED, we're going to connect it to the neopixel ring, the input of the neopixel ring. I'm not doing anything with the output, that's for adding extra neopixel strips or rings. And then we'll add add power from the 5-volt rail and ground from the ground rail. And then from the strand test, all we need to change is the pin number, basically. If you just change that to pin 13, that's the pin we're using. The only other thing you need to do is change the number of neopixels to 12. And I was having issues at the very beginning, but that may just have been because of the different settings that I set the clock settings to. I was just having issues, so I did change this to 400 instead of 800, but it seems to be working just fine with this setup. Now I'm just going to go ahead and compile this, and it compiles just fine, and then I'm going to upload it, and it's uploading. So it compiles and uploads just fine. Now, at the beginning of this video, I did think that this library was using more than it actually is. I thought it was using some other libraries that weren't going to work, but it actually works fine with the 167 right off the box. But if you did, when you're adding more components and adding more code, you're going to run into some issues on the ATtiny167 most likely, in that a lot of just the standard libraries won't work on it. For example, the wire library. If I do pound include wire.h and try to compile that, it has an error compiling. But if I did this from, for example, the do Maleve and then try to compile it, it has no issues. So that's because there's some incompatible libraries for the 167. And you may be asking, why don't you just try TinyWire? And I did try that, and that also does not work on the 167. So what you need to do is get a specialized set of libraries, and you can get this from the Digistump Arduino page on their GitHub. And in the Digistump AVR, in the libraries section, you can see that there's a bunch of libraries here, including the wire library. So if you want to use those, and you're probably going to use some of these if you're going to be using the 167, go ahead and just download this, and I've already done that. And then from the downloads folder, just go ahead and extract it and go into the folder, go into the AVR folder, go into libraries, and then just choose whichever libraries you want. In this example, I want to use the wire library. So what I'm going to do is just copy this, then just go into your home folder, go into Arduino, and then go into the libraries folder, and then just go ahead and paste the wire library in there. Next thing you want to do is check the Arduino software, and you may need to restart the Arduino program. But let's just go ahead and see. We're going to change over to the 167 again, and I'm going to try and compile it. And it looks like it has compiled successfully. So it works just fine with the wire library included in this package of a bunch of libraries. Now what this is, the DigiStump Arduino, they do have a product called the DigiStump or the DigiSpark Pro V2, which uses the ATtiny167, which looks something like this, which is a prototyping board that you can buy. So this actually would be a more suitable thing for some people if they aren't actually going into production and they just want something to do for fun. And that works for that. And so they developed a bunch of libraries that are compatible with the ATtiny167 since their board uses it. So that concludes this video. I thank you all for watching. I know it was a long video and it was a lot of different steps and all that, and I apologize for that, but there's just no way to get around it. So thank you all for watching. I hope you learned something or had fun watching. If you like this type of stuff, please subscribe.